this paper was 7 or 8 years ago. That is an interesting color scheme for the paper.
Yeah, easier on the eye.
This is normal procedure.
You want to start with anything else?
Do we want to?
I don't know.
I guess I should remind people I'm not going to be here Thursday.
Yeah.
That's kind of
Are you
important, I
going to
guess.
some conference?
PC meeting, which is also why I've been sleeping. But that's all fun. Well, so, you know, as we sit down here and we talk about the papers and you give me critiques and whatnot, so PC meeting is basically what happens before every conference, where 20, academics, industry folks, whatever, researchers will sit down, read through an ungodly number of papers, and determine whether or not they add something to the body of knowledge, and whether or not they're correct and good and can be accepted to a conference.
So basically, you guys are like the gatekeepers of.
We are the
Getting papers
gatekeepers, yes, of getting papers accepted. And so I have a PC meeting later this week, and we have online debates and angry people yelling at each other back and forth that, oh, this paper is good, this paper sucks, and so on. And then we all meet on Friday and Saturday of this week and decide whether or not the papers will get in. So that's part of the reason why I actually want you all to do the critiques here is because that's
Makes your life easier afterwards?
no, it doesn't. It hopefully prepares you for understanding how to critically analyze a paper, just like we have to. Not all these papers have gotten in. Maybe they shouldn't all have, but they all have gotten in. I think they're actually all pretty decent or okay papers at the very least. But having that skill is useful if you become an academic, or if you need to decide whether or not a paper is really useful, which isn't always the case. Sometimes there's a good theoretical paper, but in practice, it doesn't hold up. But that's the purpose of the PC meeting. So that's going to be fun. Hence also my not sleeping and being a little less responsive to emails. But that means we're not going to have class on Thursday. But I do encourage you all to nonetheless do at least a little work for something in the class, maybe on Thursday.
Well, we are doing third assignments test. One, I get to the point that I can build code flow graph and provide topological printout of the nodes and
Okay.
topological.
Good. That is actually something maybe we should talk about, since I don't think I've gotten many submissions of the third project. Are there questions about it?
I wrote an email.
Yes, you did, but I haven't had time to answer it yet.
Yeah, it's okay.
I mean, that would be an excellent time, although some of that I guess I will get to.
Then
What's the next step after creating the table with ID? Or is that called ID for each edge, for each
Sure.
vertex?
Call it whatever you want. Annotation maybe.
So annotation. What's the next step? So after pass and coding,
Mhm.
the next step is
Modify the program. Instrument the program so that this new this new version of the program can be compiled and executed. And as it executes, it will compute the paths, the IDs of the paths that it follows, and count them.
the profiling section.
Right. So what happens in the first time you run this program, you compute the encoding, and then you change the program so that as it executes, it counts how many times it executes each path. And so that second phase is where you're actually changing the program. Okay.
But the third one is not a lot of work, is it? The third one that is printing stuff.
So the third one is just reading in the file you create when you execute the program. And that file can be whatever format you want. I think an array of integers is the easiest format, I think. And all that third part does is read in that file and print out how many times the top, I think 5 most frequently executed paths actually execute.
So to do certain
Yeah,
take place.
yeah, but I mean, hopefully the sorting isn't the hard part, because sorting is built into C++. It is literally just a call to std sort.
Is the instrumentation a lot of work?
I wouldn't say it's necessarily a lot of work. It's a question of what work do you do.
To translate, it's a lot of work.
So it's doing the stuff that we presented last time, where, oh, you want to add an instruction?
Yeah, I
What
saw that
instruction is it?
video.
You know, it's add one to a number. Great, I know how to do that now. I can look up how to do that. So I just insert the instructions for adding one to a number, and great, or whatever number you need to add, right, to your ID. So we walked through that. That's essentially what it is. What we saw last time is, last time?
Yes.
Last time before last time.
Last time.
Yeah, last time. There we go. We can be recursive or inductive, whichever way you want to look at it. That's all it is. The tricky part is knowing what you want to do and where. And it's not, there's not a lot to do there. But you probably might have to think a little bit about making sure you're doing the right thing.
Okay. So think about doing the right thing.
Now, I would say if you computed your edge annotations properly,
Yes.
it probably isn't too much.
That part was easy, I guess.
Okay then, great, right?
Yeah, it's just so you left it and then now I have to go back.
Okay. Okay, so, any other questions, or shall we move on? This is a classic paper. Unfortunately, I only had time to skim it again this time, but I read it 7 or 8 years ago.
Less
So,
questions.
I think.
Yes, I haven't had time to grade them yet.
Okay.
Okay, let's start.
Okay, the paper that we're gonna discuss today is finding security vulnerabilities in Java application with static analysis. So the thing is, the static analysis has been there for a long time, but okay, let's first talk about web applications. So nowadays, everything from banking to your confidential information that is being stored and used by web applications. So these web applications, they are really important. And as a developer, you should make sure that they are properly coded, they don't have any data leaks, and they don't have any security flaws. To prevent the security flaws, we can use something called code review, which actually helps you to find a flaw in your application.
How many people know what code review is?
Is it at work when the colleagues tell that how your code sucks?
Well, I mean, kinda, yeah, pretty much. Hopefully it's not just telling you how your code sucks, but also, you know, oh, you didn't take this into account, here's how you can improve it.
Or you didn't put the space here, we have the code style requirements, please follow it.
Which is not a bad thing.
Indentation is wrong on this one, or we name these variables in this format, and so on and so forth.
That's not a bad thing, because if you're more consistent, you're less likely to do crazy stuff that causes problems. But, yeah.
And then you can retaliate on the patch that your colleagues submits.
Okay, so this is a pathological example, but it's peer review of each other's code, right? So
I
you can-
purely enjoy it, like you can use productivity, like okay, you don't want to program, oh, I have a couple patches in my code review queue, so I can do code reviews and submit that, oh, I did code reviews today. It's in the company.
Okay, but most of you haven't actually done code review then. It is essentially looking through code. Oh, some of you have. It's looking through code and critically analyzing things, right? It's inspecting it visually. And that's it.
So, moving on. Well, as they said that your peers review the code, the peers should actually know before reviewing the code. And it requires security expertise, which most of the developers lack. So what's the solution to this? The paper proposes a static security analysis that is context sensitive and takes care of the pointers as well, and is equally fast and precise. We will discuss this a bit further in the paper. So let's talk about the vulnerabilities. Okay, so there are two types of vulnerabilities. The first one is inject malicious data into web applications, and the second one is manipulate the applications using the malicious data. The first one is really common. Actually, it's the most used method of hacking a web application or injecting malicious data. So what do you mean by parameter tampering is that you have form fields in HTML, and when you submit those form fields, the web application reads the data from the fields and then processes the data. Now what you can do is you can save the page as HTML, edit the fields, and then submit whatever you want to the server. That is what is parameter tampering. Moving on to URL manipulation. URL manipulation is like if you have a bank account and you're processing a transaction, and the URL itself has some parameters that has your account number and the amount being debited. So supposedly you have some account number 1234 and amount debited as 500. If you make that amount as minus 500, it'll actually give money, it'll add money to your account. That is what is URL tampering. Then there's something called hidden field manipulations. As most of you know, HTTP protocol is stateless. So to make the data persistence, which means that you need to carry the data to the next web page, they make use of hidden fields, which can easily be manipulated going to the source code of the page, and you can make changes to that. HTTP header tampering is basically changing something called when you redirect to an error page, the user, the hacker can change the redirect to some malicious page, and it can lead to some sort of phishing. There's something called cookies, which a browser saves your information in small files, and well, you can, yeah, okay, it has your login information and some information like that, but cookie poisoning is also a method by which you can inject malicious data. Moving on to manipulate.
Before we move on to the second major bullet point there,
Okay.
what are some common trends amongst all of those things in the first bullet point?
Yeah, the first one is the most widely used method.
No.
URL manipulation.
Parameter tampering.
I'm asking you.
Do people know what these things are, first of all?
You
So-
explained it.
That doesn't necessarily mean that people know what they are.
So,
Okay,
I
so
believe this is ways for a malicious client to corrupt data on a server.
okay, and I think there were two key words there, right? Well, I heard client. I heard client, first and foremost. Malicious client. So this is where the client can do basically anything it wants.
Right.
And you should never treat the client as if it's secure. Because that's always a bad idea, because the client can do anything it wants, right? And all of these bugs up there reflect that.
Well, I feel the second part is more of a server side then. When you've injected your malicious code and you can manipulate the code on the server side.
Yeah, essentially.
All of these attacks target server.
It's just a question of
the-
where the manipulation occurs in order to target the server.
Moving on to the second part of it, well, SQL injection. Has anyone heard of it?
Yeah.
Okay, it's a very popular technique of hacking the databases, which we will look at in detail going further.
Out of curiosity, are people familiar with Bobby tables?
Yeah, it's KCD. Yes,
Okay.
this is.
Yeah, so there's also bobbytables.com, which lists how to avoid SQL injection attacks in basically every language of use. That's disappointing, but not entirely unsurprising. Huh.
Well, that's another most common method that the hackers use. We'll discuss this in detail going further. Well, then there's cross-site scripting, which has something to do with inserting dynamic JavaScript code inside the elements that are dynamically loaded in a page. and the user can use that to display ads or anything like that to the client. Well, HTTP response splitting. This is actually the one which, well, the thing is that if you have one URL going to some other, being redirected to some other URL, there's a field called refer. Oh, okay. That's not the one. Can you help me with this?
So what is the actual description?
Well, it says that you can generate 2 HTTP responses for one maliciously constructed HTTP request.
I remember it saying that if you put in a lot of white spaces in there, you can treat it as 2 separate HTTP requests. So, and then the second one, you can like rearrange their ways of how they land at the server, and basically it can be a mismatch of requests and response, and that would become.
Sure. So you're manipulating the input, and as a result, it might violate the expected protocol or something along these lines. The order in which specific events happen, or exactly which events occur when.
Okay, moving on to path traversal. Well, there are some files like theme files which the user is not supposed to access, but there may be some cases when there are some flaws and the user is able to access them. And well, other than theme files, there are other files as well which you should not be accessed, and that's path traversal, when you can go out of your path and access some other files which you're not supposed to. And moving on to command injection, these are basically, they require admin privileges, and these are used at the server side using shell commands, which is highly unlikely but not impossible. Okay, moving on to SQL injection. Okay, well, that's a simple login. It says a username and a password, and this goes to the backend of the web application, which has a database which checks the username and password, and if it's correct, it redirects you to the login user page. Well, let's see. That's a simple query, like select user, user ID, password from users, where username is equal to user and password is equal to password. This user and password, they are derived from the text boxes seen right here, user and password. Well, does anyone see anything wrong with this?
Password from user and open text. Basically,
Which means?
you can put any text, which means you can put SQL statement.
They're not being validated.
Well, you're right. Let's see. So that's the normal working of it. You enter your username, password, and it shows you your details. What if I do this? What if I add this? What do you think it does? Okay.
Password.
Well, it actually closes this username quote, and then that's called a comment. It comments the rest of the code. So that means it only checks the username, where username is equal to Bob, and it doesn't check the password. So you're free to look at any records of a username called Bob, right? It gets even better. What if I do this?
Delete the user.
Well, you can delete the whole table. You can just say username is equal to Bob, drop users, and comment the rest of the thing. You have all the access. Well, that's the whole SQL injection thing.
This is true. There was a syntax error in that previous SQL injection.
This one?
No.
Yeah.
Bob,
The drop users should have a semicolon at the end before commenting. Anyway, that's.
Oh, actually, that doesn't need that. From users where users.
before the Bob, you see in the user ID there is semicolon before Bob, and then in the code
Yeah,
below there is no.
yeah,
But you get the point, right?
Yeah.
yeah. Well, I mean, the attack was correct. It's just the explanation that was wrong.
Okay. So that's the high level overview. The hacker gives evil input, which goes to the web app.
This is very popular image, you know, all these hackers like this, like a ninja. I never seen one.
Well, that's well. If you don't want to use something else, you can use this command, a code or 1 = 1, which is always true. So that means your where condition is always true. So that's the basic of SQL. So they have some contributions to the papers. Well, as they say, let's see. So they claim that they have a unified framework, which means that there are separate types of vulnerabilities, and they can be found using their static analysis technique. Then they claim that user can specify their own new vulnerabilities. We'll look into this. What they actually mean is that you can write down your own specifications for new vulnerabilities that you want to find. And then it says that it is sound and guarantees to find all of them which are captured by the specification. Now the thing to notice here is that it all depends upon the specification, which the user has to write. We'll get to this later. And they have some precision because they use context-sensitive static analysis and improved naming, which we will look into
And
further.
of course, you all know what that means, right? Because you implemented context-sensitive static analysis.
We'll look into it as well.
I have a comment regarding the paper in general. It seems like this team wrote several papers on
Yes.
the web application. So from reading only single paper, it was unclear for me what are the contributions on this particular paper
I agree.
and what they took from previous. So like the team itself seems like they had whole body of work in this direction.
Right.
They reused plenty of tools from previous publications. So on this one, I see, okay, they claim they did Eclipse plugin. And in my mind, this is the only thing they did for this particular paper.
Right.
All the rest was reused from previous.
So what's different about this paper from some of the others we've looked at? Is there anything that strikes you as being different?
There was two improvements.
Hmm?
There was two improvements in for reducing the false positive.
Okay, so that's in terms of how they changed the underlying analysis. Is there something different about the paper itself?
I think they explained too much about the concepts that they're going to use.
Okay, so they're discussing the concepts that they're going to use.
Vulnerabilities in detail.
Okay,
Yes, and their whole approach is like 2 pages only. But before they're just explaining what's going on.
okay, so it has a different goal, almost, right? The paper is written with a different audience in mind and with a different goal in mind. And part of that you can kind of see through the venue as well, at least at this point in time. It's published to Usenix Security, right? Which is a good conference. And one of the differences from some of the other conferences that we've looked at so far is that they'll also accept very applied things. And this is an applied paper more so than deriving the theoretical results.
So basically, they devised this tool. It's actually the first paper that they had GUI interface. Well,
Yeah.
as I can recall, all others were like purely some scripts and so on and so forth.
Mhm.
So, and they devised the tool. It was convenient. Eclipse, everyone uses Eclipse for Java. So, and they just reported what they did in that, right? And that's okay too.
Depending on the venue and the
For
presentation.
this particular venue, this was okay.
Yes, now, just doing that alone, the creation of the tool would not be enough. And we'll get to that when we start to talk about the evaluation. And we'll see how the evaluation in this paper compares with evaluations in papers we've seen already as well.
Moving on to the static analysis system. Okay, a lot of definitions coming up.
All on
So,
the same page.
well. Okay, so they use the concept of object propagation problem, which has something called a source descriptor, a sink descriptor, and a derived descriptor. Now, a source descriptor is in the form of M and P, where M is the method, N is an argument, and P is the path. Which basically means that you can get a source object applying path P to the argument N of the method M. Then there is something called sync descriptor, which is of the same form M and P, which means that you can get the sync object applying path P to argument N of method M. And there is something called derivation, which is a long thing, which has a derivation method, which has a source object, an access path to the source object, a sync object, and an access path to the sync object. So this basically means that if you apply, so if you apply a path PS to an argument NS, if you apply a path source to the argument of the source method, you'll get a source object. If you apply a path to the destination of the destination object to the argument of the destination method, you'll get a destination object. And this destination object is said to be derived from the source object. That's what it says in part of the derivation descriptors.
I think that may be a somewhat unclear way of saying what's going on.
Oh, okay. We'll move on. There's something more clear.
Have we already encountered things like this?
Well, yeah, Android sync and source. The
Okay.
Android paper
Okay, which was
last week.
Floodroid.
Floodroid.
or Taintroid?
Taintroid.
I don't remember which.
Floodroid.
Okay, there we go. Yeah, but it's taint analysis, right?
Yeah.
It's taint analysis. And so this is a much earlier version of taint analysis,
Right.
just for Java programs instead of Android specific.
Mhm.
So they're looking at one of these earlier tools that provides an actual solution for taint analysis. And this is also a static solution, right? You can also have dynamic taint analysis. This is one of these early static solutions. And so we're going to see some very similar problems, although it might not be immediately clear that they are similar problems. And we'll see how they're solved in this paper.
Actually, a lot of definitions again. And this is the thing I was talking about: the source object, the sync object, and the derived. Okay, so do you have any questions in this part? Is anything unclear?
I mean, that would require first for us to read through the slides.
Well, I just explained the thing that, okay, so as I was saying that there is a source method, there's a source argument of that method, and there's a path P that can be applied to the argument of the source method to get the source object. Right.
So I think one of the things that might be unclear as of yet is what an access path is. Am I correct in that? Okay. So I think that's,
He specifies a paragraph saying that access path can be anything, a sequence of field accesses and array access.
this would be a good thing to explain.
Okay.
I think that you having a source object
Right.
and a sync object makes sense. I don't think there's any confusion about those two entities here.
Right.
Intuitively, people probably understand what that means. The question is, why do you need something else in there?
Derived? The derived part?
What? Access path.
Well, the thing is that the source object, from what I feel, is that the source object might be derived again and again, and the content might be copied into some other object, which which you can say that might be referred by some other object. And to know exactly what the source object is, you can trace the path back. Is that what access path is?
Okay, so in the Java program, what the source project, it will be some get string from a
Right.
field, right?
Right.
And then sync object
It will be
will
some
be
execute
what?
query, something like that.
SQL query, right?
Right.
And then derive What if
Well, derived means that, see, if you have a source object, you get something from the get username,
okay.
you store it into one variable. Then you
Yes.
have another variable reference to that, making reference to that variable. Then you have something else referring to that. But in all, they refer to the source object.
Okay, so the links between the source and sink
Right.
are all derivations and access.
Those are the derivations, those aren't the access paths.
Okay.
So access paths is basically saying that, well, okay, you've got one object. Through that object, you can get to other objects, right? How do you get to other objects through one object?
Okay.
Anybody can answer this, right? Let's say I've got some object, let's say I've got a car object.
Mhm.
This car object probably contains some tires, maybe it's got a windshield or something like that. Maybe the tires, well, this is a
Isn't
horrible
the access
analogy.
path, do you have the access path, like dot something?
Yeah, that's it. So you're saying I can access, through this maybe sensitive car car is horrible. Through this sensitive object, whatever it may be, it's got some field foo. And maybe field foo has another field bar. Maybe it's got an array, bases or something like that. And this holds 10 different bases. So you've got this way of accessing things through these chains of indirection. That's really what the access path is describing there.
Oh, that's very common in Java, obviously, right? You have
Yeah.
object and object.
Yeah, but I mean, it's the kind of thing that you've got to take into account and you've got to work through in order to understand the rest of this vocabulary. If one link in the chain is gone, then suddenly this becomes very tough to understand, or to understand precisely.
Moving on. Well, do you have any questions about the? Yeah.
So basically, sink is something else, because the descriptions are the same, the source object and a sink object.
Right.
So sink is the SQL thing, source is the string.
They have different
for the-
methods. The M is different in both the cases. And argument, I mean, everything is different. Even though they have the same name, M and P, they're different methods, arguments, and access paths.
So for instance, maybe I call a particular method, which might be dangerous. But it might not be dangerous for all of its arguments. Maybe it's only dangerous for one particular nested subfield of one of its arguments. So only the particular bar of a foo passed in as the second argument is dangerous. And everything else is still okay. And these specifications allow you to be very, very precise about saying, the first argument doesn't matter what that is, but the second argument, that represents something that is going to get leaked. And maybe it's only a particular subfield of the second argument. And that means, that's why the access path is important, because it allows you to precisely say, well, you can pass in some argument to this, but it's only a specific subfield or something like that of this argument, of this specific argument that'll actually get leaked.
Moving on to the derived descriptor, we can say that an object O2 is derived from object O1 if we can apply any access path to get from O2 to O1. Any questions? Well, we say that the object is tainted. Tainted means that it's flowing from the source to the sink. If we can find a derived relation between the sink and the source object. Right. And they claim that they give the definition of a security violation, which says that if a source object flows to the sink, then obviously the source object is tainted and is going to the sink, which is called a security violation. Okay, this is the thing I was pointing out, specification completeness. So, the most important part of their static analysis is the specification. They always claim that it can find all the vulnerabilities matching a specification. Now this specification is nothing but consists of these descriptors we just talked about. That's the source, the sink, and the derived. And then the point is that a developer has to go through the API of the libraries being used or the code being used to actually find the source and the sink methods, right? But my question is that if you have a web application that has a specification already there and you intend to use a new library, are you willing to are you willing to create a new specification again? Are you?
Yes.
Isn't this the same thing as code review? I mean,
Yeah, you just go to manager and say, okay, I have this idea. And then you have couple meetings. And then you propose and propose, push and push and.
no, but what's the point of this if you have to write this thing yourself? What's the point? And the whole static analysis depends on the specification.
Like, isn't it still useful in the fact that at least you don't have to go through your whole code like a billion times to look for like minute things? Like things that you build out of your specifications that maybe you don't see yourself?
No, but any comments on this?
There should be a way of automating it. So.
Well, they claim that they run some tests and they miss some specifications, they include them again and some stuff. But then again, you still have to read the APIs to find the source and the sink methods.
One of my previous jobs, I had to create specification for a certain tool, right?
Okay.
Could you imagine how far the end product was from the specification? And no one complained.
I know that happens. That always happens.
Because by the time you start programming, like everything what was your specification based on changed already. It's no longer available.
There are actually a few issues with that. That's actually one of the major issues with verification of software as well. We talked about verification and model checking a little bit, where we're proving properties about software. You can do verification in two different stages of software. You can do it on the requirements, or you can do it on the code itself. One of the big problems with verification of requirements is that usually by the time you verify the requirements have changed.
Right.
And so one of the big shifts we've seen in that is that you end up trying to verify the code itself now instead, which is why we have things like the Yogi tool, which go and try to verify drivers at Microsoft. Well, the original tools were for verifying drivers, now it's just general. But the same issue is here, where, you know, if you don't have something that is general, then maybe it's not going to apply. What are the problems?
So then you're gonna miss some errors or flaws if you don't have the specifications properly done.
Okay, so
I have a question. I thought this process of finding sources and things should be like automatic. Wasn't it like this in the previous paper that I presented?
okay, so let's talk about that.
But that's 2014 and this is 2005.
Very little difference with respect to that issue.
Okay.
I think we can reason through why. And I can force you all to reason through why. Make my life a little bit easier. Pretend to sleep a little bit. Why? With Android, we were looking at Android. We had sources and sinks, and they were consistent. We didn't say that we had to rederive new sources and sinks for every app.
Because of their framework?
What
They-
framework?
They used their previous project called SUSE something that they would that the SUSE would give them all the sources and things, and they would just use them for their analysis.
Okay, maybe this is a bit of a cop-out for it.
Android friendly?
Android framework?
Yeah, with the structure predefined, like all Android apps have to follow certain patterns in
Okay.
order to be considered as such. Should be like.
But the applications can be very.
Okay, you have a rebuttal? Before we get to the rebuttal, let's finish establishing the first argument. So why is that okay in Android? You say because there's a formal framework in
Okay.
Android that you're using. What does this mean?
It is one company controlled, and they can tell you what you have to do in order to get into the system.
So the ways that you can get input and the ways for having output are predefined.
Right.
They're known. So you know what potential sources and sinks are,
Yeah.
because they all go to the same APIs, unless you use native code. But they didn't handle native code entirely, right? They kind of said, oh, native code. So yeah, if you have these predefined APIs where everything is known in advance, sources and sinks are done. Okay.
In the application, we have also a predefined API, so we can say that if this function is called, we can say that it is the same.
Okay.
There should be a way, because like, there might be like multiple APIs, but anyways, someone should use the existing one, so.
Okay. Additional thoughts? Rebuttal?
I think there are a variety of methods where you can have an input, or you can use different technologies. I mean, it's all defined by the basic framework, which is set by HTML. But
Front
how
end
you
is
process
can be
those
different.
inputs is also important using different languages.
Okay, okay. So let's constrain ourselves to just Java for a moment, for convenient purposes. In the context of Java, if we assume that you're doing it through Java, issues? Okay?
I have a question, so in Java, with web, is it possible to consider everything that comes from HTTP site as a potentially user-generated input and as a potential sources? Like everything, even in the Kira showed the source code with this password and login. Is it possible to keep every single user and password automatically in the source?
It's certainly possible. In fact, you should.
Yeah.
Any user
So that
input
would be-
should be tainted.
You can use validators.
Well, that's how you might get around it.
Right.
So that's where you're talking about sanitizers, which this work is also concerned with, really.
Okay.
Which will come, we should probably come back to that, so I'll write that down.
Sanitizers.
Yeah. Because that plays a big role, and there's a lot of work on that as well. But just in the context of Java, should we be able to predefine things?
Maybe some of them.
Okay, maybe some of them. Why yes, why no? Can we come up with some rationale?
Because some functions like string manipulations, you're going to use them from the normal libraries that Java has.
Okay.
There might be something else, some user-defined library that you're using.
Okay. If we're concerned about sources and sinks,
Right.
can we constrain what those things are?
I think we can.
What are sources and sinks?
Sources come from the input, like,
Text fields.
Okay. Okay.
Exchange arguments.
yeah,
Okay.
Like separating events.
Sure, sure. And those are largely done through pre-existing APIs. Maybe a wrapper around the pre-existing API as well. But even that's probably still using the pre-existing API. Either that or native calls, which we'll throw our hands up for now. And sinks?
from HTTP request. From the server.
I guess whether you're looking at a client-side sync or a server-side sync or what have you, I could see that as being a source, depending on
Okay.
which role you're playing in the
Yeah,
system.
true.
But either way, you're looking at I/O largely. I/O or something that interacts with the system, maybe executes something. These are largely things that are pre-identifiable. as long as you can see through whatever code is being analyzed. It's either going to be things that are predefined inside Java at least, or wrappers around those predefined things. And as long as you can see into the wrappers, it should be okay. Have I convinced people, and can I maybe let some of you convince me otherwise? I'm playing, not devil's advocate in this case, but I guess the angelic advocate or what have you. I'm not actually arguing for the system. Can you convince me otherwise?
Could be too many.
Could be too many? It's possible. I do think there's a reason that they did their evaluation on Java. Put it that way. Right? Because that gives you the constrained API.
Yeah, but why do they need to like mention these things?
If you look at a different language, then creating a new specification could be tough. That's true. This is an argument for something else as well. It's an argument for having a library of specifications, which is one of the things they've done. Yeah, as part of their system, they created a library of these specifications for sources and sinks. And so that's kind of one of the things that
Wait, I thought, are you talking about this set of known vulnerabilities specified in GPL?
Are you talking about the subqueries? The source and the sink query? The subqueries, right?
Yeah.
Okay, we'll show you.
Right, and this is why they can talk about this. It feeds into one of their contributions. Is there any reason why this bottom thing is problematic in places where you don't have a library? So let's suppose, for instance, that you're writing a new app, and you don't have these patterns already created.
You have to create them yourself.
Okay, what are the problems with that?
You might not know what to write.
Yeah, basically. The underlying motivation is that, well, you need someone who knows how to do security analysis.
Expertise.
Yeah. So basically, that's the bottleneck. If you use this in a different system, you got to have somebody who's a security expert to do the upfront work. Once you do that upfront work, you can do it once and take it forward. And even if you don't change frameworks within a single app's development, you can just reuse that framework over and over again without a security analyst going through it every time. So you do the work once, and you can reuse it.
Okay.
So that's the benefit, but you've got to pay that upfront cost either way, or somebody has to pay that upfront cost. Maybe that provides a little bit of extra clarity on some of these trade-offs. Maybe everybody just fallen asleep at this point. Dreaming about happy little trees because you all watched those podcasts. Okay, yeah, we
Okay.
Very simple password.
yeah, I can't endorse that password length.
That's a pin, not a password.
That's still brute forceable.
Is it a number? It's there on the camera, that's okay. I'll save it.
Now we know.
So now moving on to pointer analysis. That's the first project. Okay, so can you determine by looking at these two statements that these might be related? Can you? Can these be same objects? Can you determine by looking at them?
It's incomplete. What is the query?
There might be a link or might be not.
Right. So, well, static. Okay. So, static analysis would say, there might be a link. Let me consider this as tainted. So, to be precise, we use pointer analysis, right?
I mean, I'd be careful about how I frame that, maybe, because pointer analysis is a static analysis.
So, without pointer analysis,
Without some additional information, it's kind of tough.
Right. So pointer analysis can help you answer the question like, are these related? Yes or no. So the next question is, someone told you that there are no pointers in Java. Well, huh? Well, they are actually. They are the references. Okay, just moving on. You didn't like it, that's okay.
Oh, no, my bluff was to the, my bluff was to the idea that there are no pointers in Java. I hope nobody here thinks that or thought that. That is an egregious abuse of an undergraduate education. If people who said that.
Well, that's okay. So, yes, there are pointers, but they are hidden under the references.
Yeah.
In disguise. So, they're just actually pointing to the heap allocations. That's it.
Java trivia on Java.
And helping you with the general
Sure,
knowledge.
sure.
as well. So,
Marketing strategy.
okay, so how does pointer analysis help us? Well, the slide we just saw, we were not able to determine that whether they were the same objects or were they related. What pointer analysis helps you is that you can, with certainty, you can say that a pointer, an object that has been passed in, and the object that is being derived out, they have some sort of relation. Pointer analysis helps you with that, no matter how much long the flow is, but it'll help you determine that. Okay, so it doesn't matter what the variables refer to, and we can follow the object through the program flow. Huh, wow. Okay, finding violations, status.
Let's back up a second, actually.
Okay.
Okay. So, do people agree with this? Disagree with this? Any comments? Or are we just gonna let this fly by without discussion? Did I catch people napping? I caught people napping. Yeah.
Can you explain why the second point? Why doesn't matter what you use?
It doesn't matter what the variable referred to. I mean, you can have any variable referred to anything else. It might not be your source object directly, but it might be flowing down from the source object somehow, and you can determine that.
So I think you probably agree with this high-level description, but this high-level description maybe glosses over a lot of problems.
Okay.
Because in general, when we talked about static analyses, or any types of analyses, we talked about them from two different perspectives, and they gave different levels of precision based on their approximations,
Right.
right?
So anyways, it's not complete because it's an approximate.
It is over approximated.
It's over approximate, yeah, yeah. So it gives us some information. It's gonna lie sometimes too.
Right. It has some false positives. So.
Yeah. So you know, bear that in mind. That's kind of thing we have to keep in mind. Maybe this was unnecessary to bring up, and everybody.
That's why I didn't say with certainty. I said yes.
Yeah. I mean, that's you corrected yourself correctly. But I'm not sure if people were just sleeping through the rest of the material. Everybody just said, okay, we understand that. Let's move on. If so, great.
Okay, that's. So I'll just give you the gist of it. They actually use something called points2, which has a relation between a variable and a heap allocation. So from what I understood from this whole equation, is that you have certain heap allocations starting from V1 or H1 to HI, and they can be derived. So HI or VI can be derived from V1 or H1. They have some relations between them. These are all the source. The source is being related to the ith thing here, or the kth thing here. And then the object that is after this, that is allocated after this, the next one is the sync object. So basically, even though the source object was the first one, and you went down k levels, still the object was passed on, and it's being thrown out of the sink. That's what I understand from it, and that's what they mean by a security violation. Is that the correct understanding?
Yeah, essentially. I mean, it's just looking at the flow of these relationships.
Any questions? Let's see.
It's a somewhat strange presentation of things, I think, because it does focus on the allocations, which is not what the FlowDroid system did, right?
But
It included allocation information, but it didn't focus on it.
But I have a question. So that means every single user input will be considered a security violation, right? Like, because every single user input that is being used further down in the program, it will be reported as a security violation. Am I correct or not?
If it goes to sync.
Because user input will be considered as the source.
Right.
Somewhere down the line you use it, okay, that's a sync.
Stored into database.
Hmm?
You store the user input into
You store in, but that means like, if that will be true indeed, that means like every single thing that user will input, but that's not happening in the real life, right?
Okay,
But it can.
there's something that
Like we do all these checks, if,
there's something a little bit subtle in there, which needs to be taken into account, and that is what I mentioned before: sanitizers. Right. Well, you're describing if. Why were you saying if? Let's go into that.
like,
Let's check.
okay, there is, user can enter some integer, and you want it to be in certain range. So that means you will do this if-else statement, and then you decide whether to input this value into your database or not, right? So that if you do it in proper way, well, supposedly there shouldn't be any security violation. Supposedly, if you can even, user with malicious intent won't be able to
Sure.
do
So,
any bad actions.
so the question is, can you break this chain of transitivity with some kind of sanitizer? And the answer is yes, you need to be able to express that as well.
But they did not really explain that.
Not so much in this one.
Okay.
Yeah. But depending on how you look at it, you can view this chain of transitivity being broken by a sanitizer. You could say that you're creating something new during the sanitization process that is safe to pass on and that doesn't satisfy the points to relation.
Is it only me, or they never talk about implementation?
I mean, they discuss, so for example, they describe PQL.
Right.
The guy wrote a whole book on it. I
Yeah.
Googled it, but it's
It was
separate
his
publication.
dissertation. That was part of Lucia's dissertation.
Okay. So moving on. Or
Do people accept the idea that you could say, oh, you know what? Here's a sanitizing method, and the taint stops at that point. And so this flow of transitivity of a violation stops at a sanitizer, at which point we're cleaning the data, and it's no longer input data, it's useful data.
So does it use the constraints on the input checking?
And usually you'll have a dedicated method that does exactly that. So when you pass the data through this method, which is declared as a sanitizer, then from that point on the data is safe. And just like you can specify sources and sinks in that notation they were discussing before, you can precisely specify sanitizers as well. So, this field passed into this method whether it was tainted before or not, once this method executes, it's clean or something like that.
I want to raise
Concerns?
no discussion point regarding their tool. So they in analysis they claim that that they report out of 41 potential security violations, 12 were false positives. So I'm wondering if you would implement such tool in real life. 12% is almost 1/3, 29%. 12
Of
false
41.
positives
Mhm.
is almost third.
Right.
So if you implement this tool in real life, it could potentially annoy developers.
But
What
they
do
have
you think?
explained that what is the cause of that, and they are going to improve it.
They promise they'll improve.
Because they had I can't remember the exact thing, but they said that they had an approximation and this is because of that
Okay.
happening, and they're going
And
to
the
focus
false
on-
positives were in one particular app, this WebGo.
Mhm.
All 12 of them were in
Reason
one
was,
particular.
I think the reason was that scenario was not possible in runtime, and they mentioned that by a simple change in the source code, that code positives can be eliminated.
Which is a little unsatisfying, maybe, to say a simple change in the source codes. But one of the things that should have been happening even from 2005 onward and should increasingly happen is that we develop our code in conjunction with good tools so that the code is easy to analyze as well. So I do agree with this idea that changing the source code should be able to decrease false positives. It makes much more sense if you develop the source code using an app from the beginning. Just like we have things like continuous integration now, you know, every time you make a change, commit it, tests get run, and so forth, you see how it impacts the code base. There should also be security checks every time you commit something. And that way, as soon as you commit code, the cost of making it not produce these false positives is low. That should be the case, but that's, you know, this is in 2005, that's still not the practice yet in most places. It should be, you know, hopefully education fixes that, but it's still a problem.
And since you mentioned 2005, so it was 10 years ago, I was wondering, does this particular paper targeting Java application still still important today? Because since the time we have like whole bunch of different technologies, like I don't know, HTML5,
Is it still
Cloud
important?
is-
Yes. Are there things that are improvements on it? Yes.
no, in the sense that people don't maybe like if they create a web service, they're
Mhm.
not necessarily gonna use Java. They're gonna use some.
But still, the thing is, the problem is with SQL.
Hmm?
The problem is with the SQL query that is being
But
executed.
they target in Java only, right? They don't target in other.
This is true. That doesn't mean they aren't adaptable. It's a lot harder in scripting languages. So you throw this into Ruby or Python or something like that,
Exactly.
and the dynamic nature of the language makes it a lot harder to analyze. This is true. One of the reasons why using static languages is a little bit safer is that it allows you to reason about things a little bit more rigorously. That is a big problem in general. Those dynamic languages make things harder to make guarantees about, in general. There are some other issues with the whole false positive issue, or rate as well. In general, a high number of false positives makes something unusable. So for bug detection issues, for instance, at Google, they have a 0 false positive policy because the scale of their code is so large that any non-zero false positive rate ends up producing a large number of things that require inspection. Is there any reason you might justify it here?
What would justify what?
Having a false positive rate that's non-zero,
Well,
or having a substantial false
We're
positive
talking
rate.
about one web application at a time.
Oh, yeah, well, one web application at a time, yeah, maybe, maybe not, but there might be some other stronger justifications. So I said bug detection at Google, they have a 0 false positive policy.
That means it's very careful when to report the flaws.
This is true, this is true,
Like
for bug
almost-
detection.
Almost most obvious bugs.
Okay,
can be detected
how is this different?
and reported. Here they detect everything that could look like a bug, actually.
Not just like a bug though.
Potential.
Yeah, it's about the difference in risk. So these are the sorts of things that you weigh into account when you're looking at the false positives and false negatives for a particular purpose, right? Security can be much more mission critical. Your risks and liabilities are much higher. So taking this into account is good. CanSec West happened last weekend-ish, which is a security conference. It happened in Vancouver, actually, last week. There was one guy who found something like 4 security vulnerabilities and walked away, I think, with like $250,000.
Pound to one?
Hmm?
Pound to one.
Yes, exactly. Yes, yes. I'm not sure how many people are familiar with the competition you just mentioned, but basically, you make a security vulnerability, you get rewards, and potentially, a cool laptop or something like that. And so, guy went in, exploited a couple different browsers in a matter of seconds, and walked away with lots of money. And that's because security vulnerabilities are so important. So false positives in this domain are more acceptable than false positives in some other domains. I was going to send an email about that actually, just because there are a couple articles about it that were around last week. Just an indication of just how much security vulnerabilities are still relevant today. Because I think this guy used a buffer overflow and a couple other things that we've talked about, and walked away with a big payday. Now it took time in advance to create those attacks, but that just gives you an indication of how profitable this kind of expertise can be.
So buffer overflow, how is it a security issue?
Well, just like we talked about last time,
It crashes the app?
we talked last time about how to translate a buffer overflow. Yeah, wait, you missed out on the presentation that could have earned you $250,000. Congratulations.
That's okay.
It's on YouTube. You can rewatch it.
But essentially, if you have a buffer overflow and you carefully construct input for it,
Right.
you can execute arbitrary code.
Oh, okay.
So that's problematic. And so this guy did that and walked away with lots of money.
That he did exactly the same approach as the previous.
A little more complicated. I mean, just as tends to be the case, the research paper there gave the seeds of the problem and made it simpler than it actually is. If he combined a couple different attacks together, and as a result was able to exploit, Chrome and Firefox and a couple other things, and walk away with money because of that. In particular, if you're able to exploit Chrome and do arbitrary remote code execution, Google will pay you handsomely.
First project.
Yeah, so that's your new project.
Nothing for
whatever you got for projects 1 through 3, throw it away. Maybe you're happy about that, maybe you're not, I don't know. And now your goal is to make yourself money by finding a bug in Chrome. It should only take about 6 months, and you've got a week or 2. No.
I was thinking Chrome is open source, so you develop in
A
the
bug.
Chrome, and you inject a bug in there.
They won't let you go.
And then you exploit it, and then you can know it.
They have enough review on code. They use good tools to detect problems already, right? And they've got enough review that they
You
will.
have to go high into hierarchy to become decision maker.
So you're saying that you're going to go and become high enough in the Google hierarchy to make a lot of money in order to make you know, the
Make
same
money off
amount
the
of
fund.
money. That's,
That seems like a
Okay.
plan.
that's a plan. Okay, but, I mean, that explains the false positive rate being acceptable, right? It's about the domain. Security vulnerabilities create huge liability. And I mean, there's just another settlement for Target recently, right? Target, I think?
Yeah.
Because of their poor security, which, you know, caused loss of credit card information and other stuff like that. These are big issues. So false positives can be okay in this domain. Fewer the better, but use your judgment.
Yeah.
Well, what they use is context sensitive based on something developed by Bailey and Lamb, some paper. Well, the gist of the main important part of this is that they actually use binary decision diagrams that are able to let you encode as many as 10 raised to the power 14 contexts in a program. We did assignment 2 and we were supposed to do only 1 or 2 contexts and it was difficult.
Ooh, I'd be careful about phrasing it that way. Your approximation was to have that level of context sensitivity. You could have had many contexts that are still distinguished
Okay.
at that level of context
Okay.
sensitivity.
Right.
Right? So you look 2 steps back and call site context sensitivity.
Mhm.
And that distinguishes based on the call
That was
sites.
sensitive.
You could have many different contexts. You know, foo can call var, foo can call baz. Those are 2 different contexts.
Okay, so you can have many contexts like that.
Yeah.
So he's talking about context and not the sensitivity, right?
Yes.
Okay. So, well, the important part is that the constraints of the specification can be translated into data log, which we will look going further. Has any one of you seen a binary decision diagram?
This is a core representation, and it's in the art of computer programming,
Has anyone?
which
Would you like to see one?
Yes.
this would be a good thing to show. Yes, fundamentally, it's a good
See,
thing to show.
voila. Okay. So this function, would you like to explain, please? This function is somehow represented into this.
It is. Okay.
It is there for you.
So if you look on the left, you can see a truth table, right?
Right.
And you can see a tree representing the truth table. And it should be obvious to everyone how that works, right? How based on the variables, based on the values of every variable at every level, it creates this clear process of making decisions that tells you what the final outcome will be, right? Was x1 true or false? If it's false, you go one way, true, you go the other way, and then at the next level, you make different decisions. And so you can represent an arbitrary function over 3 Boolean variables using that tree. Binary decision diagram is just a compact representation of that same information. That's it. By capturing the redundancy at different levels, right? So what are the differences here? Well, if we look at x1 going to x2, if you have true, right? Well, the decisions based on x3 are the same either way. They don't matter, right? And so this is, I guess this is the right branch. True is a solid line, right? So if we look at the tree, you take the right branch, you go down to x2. Well, the value of x3 doesn't matter. If x3 is true or false, you'll get false if x2 is false. It doesn't matter. And so binary decision diagram just directly encodes that in a DAG. It's a compact representation of a Boolean function.
It's actually exactly the same as that one, it's just
The
all
meaning is the
ones
same.
go to the.
The meaning is the same, the representation is different, right? Because
So the representation is different only at the bottom level, right? So we can,
it's not just the bottom level. So the first thing to say is, well, okay, you only have one representation of 0 and 1. So that's the first reduction from the tree. We found all the things that were equivalent at the bottom level and reduced them to point to the same thing. And then at one level up, you find all the things that are equivalent and you reduce them, essentially. And you keep performing this reduction. And what this lets us do is eliminate x3 entirely if x2 is true, because it doesn't matter. So it's a more compact encoding. We've taken something that has an exponential representation, and we've come up with something that is, okay, worst case, it's still going to be complex. But in general, it has a much more efficient representation. So you can actually hold it in memory. That's the big thing. The problem with contexts is that there are so many of them, they take up so much space, that they just end up being tough to reason about. They don't scale well. BDDs do scale well. Now, the difficulty with BDDs is that transforming something that is in exponential form into an efficient, let's say, because this might be terminology that's actually used, a reduced ordered form. There's actually something called an ROBDD, which is a reduced ordered binary decision diagram, which gives you a canonical reduced form for the actual expression. You got some guarantees about things. That translation process itself is costly. How many people have looked at different representations of Boolean formulas?
Yeah, actually, I was trying to make a different representation of that formula. So the compact version is probably a simpler presentation of the f of.
It is. That's exactly the point. That's exactly the point. A BDD is a compact representation. It is equivalent.
Is it obvious?
It means the
right
same thing.
Is it? Can you tell by looking at that?
Yes. So for instance, look at x2, right? There's an edge from x2 directly to true and directly to false. It doesn't even, if you take the true branch from x1, there's a branch from x2 directly to true and directly to false. That doesn't even consider x3 because it's irrelevant.
But from the formula, can you tell from, so x3 doesn't matter in the formula?
There's a process for factoring the equivalent behaviors out.
So how can you, so what is it being factored?
So if you put x1 and x2 in there, doesn't matter what x3 is, it will always be true or false, for example. So you don't need to capture information.
But the same thing is for x1. So same thing that you said is for x1 too. Right?
We only see x1 once up there as well. Right? We see x1 once up at the very top, and it says, okay, you take true, you go this way, you go false, you go that way. Right? So it works to eliminate the redundancy. Now you're right, there are some other subtleties in there in terms of what the best representation is. Maybe it's better to put x1 lower down versus higher up. And this is why the process of finding the smallest encoding can be expensive. That is actually a problem. Like, should x1 be the top of your decision, or should it be somewhere in the middle? But how many people are familiar with the art of computer?
It's an art. Art of.
Yeah, the art of computer program.
Yeah, I tried to start reading this book several times and I failed at this part.
It's basically an encyclopedia of known problems that are fundamental in computer science. It's classical reading, but it is an encyclopedia. So you have to read encyclopedias.
There is famous foreword by the Bill Gates that the person who will read this book entirely should send him a resume.
If you read
Is it that difficult to read?
it's
Well,
massive. I mean, try reading an encyclopedia.
Oh.
It may not be hard to read, but retention will be a problem. But in this case, it's harder to read than an encyclopedia as well. It expresses these problems very well. Knuth, the author, is very, very good at expressing problems. He's very famous. But also the original author of Tech, right? The Tech.
Oh, this is very.
Yeah, but This is in one of his versions as well as being a fundamental problem. And it is a fundamental problem and a fundamental representation for formulas. But if people are familiar with like translation between CNF and DNF
Yes.
formulas?
That's
Okay,
the
people,
same.
okay. I mean, there are those same issues as scalability. Translation from one to the other can be a very expensive process, just like translation into this format can be a very expensive process. It's analogous, at least. Which makes things moderately clearer for part of the class. Okay, best effort. But people do see that this is a compact representation, that's why they use it. I think that's, as long as you know what this is, you're getting something out of it. So we can move forward.
So why do we need binary decision?
Scalability.
Yeah.
It's all about scalability.
And you don't need to uncompress it to use it, there's something.
Right, well, let's take a look at it. Let's take a look at it. So let's say that we have some values for x1, x2, and x3. What do we do? To figure out whether something is true or false, what do? We traverse the tree. And it's not even a tree anymore. It's this really efficient encoding. So you just follow the path, and at every step, true or false, left or right. That's it. So it's really easy to use, and it's a compact encoding of the underlying problem.
But what does it have to do with the topic? Okay, encoding?
They reduce all of the queries to this format.
Oh, okay.
They use BDDs to efficiently represent the context.
Yeah.
Clear?
Do you have an example?
The paper doesn't really have,
No, that's out of the paper.
yeah. So the discussion of, what's in this paper versus other papers, that is in the other papers. So this is the applied version that talks about, the uses of their theoretical results. The other papers,
that they are using?
yeah. So they wrote several papers on this topic, and their other papers discuss those formal results. And they are interesting papers. They're worth reading. There might be a little bit of a tough of a read in comparison to this one, but that's okay. But yes, essentially this paper is using their previous results.
So moving on, how does pointer analysis help precision? So the previous two approaches, they were either precise or they were fast. Or they were either precise or scalable. Either one of these. But they couldn't be both at the same time. So the thing is that lack of precise information leads to high false positives, which is a bit of a problem. And then they use context sensitivity information to improve precision. Now context sensitivity keeps the information, which means that if a method is called in a particular context, it will be separate from some other method or variable is being used in some other context.
Or the same method or variable used in a different context.
Right. So that's what context sensitivity is, differentiate between two different contexts.
Which everybody is comfortable with at this point? Maybe? You've worked with it up close and personal.
Can you say that the third assignment where you have to differentiate the paths inside loops is also kind of context sensitivity?
I would say no. So the third project is not context sensitivity.
Second.
Yes, the second project deals with contexts. The third project deals with paths.
But then if there are two separate, sorry.
No, this is it all adds to the meat and the knowledge that everybody picks up, right? So that's good.
Say there are two DAGs inside a single loop, and for each DAG, the paths, the numbered paths would basically be the same because they are different DAGs. And say it turns out to be the 0th path which I would be taking both those DAGs. Then I'll have to identify that which loop I got that path from so that I can trace back the path.
Okay, I see your argument. The core of Project 3 is not about context sensitivity. There is a Not even really a 1-to-80 context sensitivity. You're just looking at which method you're in. So you're not even looking at the call site. It is a type of sensitivity, but it's really, really imprecise. But yes, you do have to care about path 0 in one method versus path 0 in another method. That's true. That's true. I'll accept that. So that deals with essentially not the call site context sensitivity, but a one level, are these in the same method or not, basically.
Usefulness of context sensitivity. Well, there's this example that class data source has a constructor data source and uses this pointer reference to store the URL. And then you create two different objects of the class data source, ds1 and ds2. And then you just throw them into a string. So the thing here is that in case of context insensitive analysis, the program would merge both of these calls into a single call, and it would end up being either this one, the HTTP local, or either get parameter.
And you wouldn't know which.
Right.
You
It could
conservatively
be
say
either
that
one
it could
of
be
those.
either.
So he is considering for some reason as this one being tainted. He said that the S2 is tainted, and context insensitive considers S1, DS1 as tainted as well. So both of them are considered tainted, even though this one is not tainted, according to the example. The context sensitivity helps us differentiate between these two, and it tells you that only S2 is tainted. My question is, can this be tainted as well if there's a username or password in it?
Depends on your policy. I mean, that boils down to what your policy is.
Okay, well, that's the whole thing written down here. You can read if you want. You guys want to read, or should I go ahead? Okay, coming to the important part. So, we talked about data log queries, BDDs, and everything, but at the end, they say that the source descriptors, these sync descriptors, and the derivatives, they're really important, very difficult to write in real life. So, there's something called PQL, which is called syntactic candy, or sugar, syntactic sugar, for the data log queries, which allows a user to express these same specifications in a much more friendly and Java-like syntax. That's the whole point why they're using PQL. And also, the data log queries, even though they give complete control to the user, they expose a lot of programs' internal representation, which can be dangerous. So they prefer to use PQL instead of the data log queries themselves. Well, PQL syntax has basically three things. It has something called uses, matches, and returns. Well, I'll just go over them since they're not much clear to me as well. Maybe you'll help us. So the uses clause tells you whichever the variables it's going to use. It is something like if you're going to get some parameter and you're going to store it into a variable and you're going to use that. So that's what the uses does. Well, then there's matches. Oh, it has to. It is some sort of a where clause. You match with something. So what exactly are you matching? Are you matching the derived objects?
Oh, partially? I'd have to go back through this actually.
Okay. Oh yeah, actually it's looking if the source object that is being used matches the source subquery, which we'll look into after the slide.
Yeah, so events can be things like assignments to a variable from a tainted variable,
Right.
for instance, right? I mean, essentially what you're looking at is ways of expressing the rules that we saw before for taint analysis, but in a more usable way.
Okay.
Okay, so you don't have to explicitly write, use def information in a low-level form, which we were looking at before.
The specifications.
Yeah.
Okay. So, and then there's a class called returns, which gives you all the objects that matches the events that you're looking at and returns them. This is a bit unclear.
I think it's clear, it's just saying that there's a.
I don't know, I cannot
there's
explain this.
really explanation for things we have like we have talked about before.
So think about SQL, right? SQL is a language for specifying queries over data, right? This is just the analogous thing for specifying your queries over programs.
Okay. So the return can be some select star from?
Oh, yeah, I mean, probably a little more specific than that,
Okay.
but if
So
you
it's
want-
something select user.
Yeah.
Well, it's some sort of a select clause.
Yeah.
And the matches is the where command, and uses can be select whatever it is being used.
That's my take, roughly.
Okay.
Disagreements?
Well, any questions? Okay, we discussed something about that they give you some APIs, that they have pre-identified some sources and sinks. You just see that there's a source object and there's a function. A source, derive, sink. These are PQL subqueries that I assume is provided by them, which look something like this. So these pipe symbols, they are nothing but you can have either one of these, some sort of wildcard, like you can have source object equal to this, or this, or this, or this, any one of these. So they have identified all the list of sources, and the object that you are using can be any one of these. Similarly for the sink, and similarly for the derived. They have created some subqueries.
Yeah.
So they're providing it themselves?
So they're giving you, like I said, a library,
Right.
of things to use for the patterns.
And if you don't have it, you can add it into this.
And I think it becomes clear if we look at these examples, just what's going on. I think. So let's take, for instance, the source query. And we see in there, we've got returns, source object. We've got uses, source array, and rec. And we've got source array, at least one of these patterns in here is source array equals rec.getParameter values, and source obj equals source array. Right? So what is this telling us? I think this makes it a little bit clearer what the language is doing. Right? This is in general how you would figure it out, by looking at what's written here and working through it.
Looking for specific function calls.
Okay, yeah, we're saying, okay, there are some specific types of things upon which we are interested in their, or for which we are interested in their events, and these are the uses things, right? So let's look for events on source arrays, or on string arrays, and on HTTP servlet requests. And in particular, we've got this patterns for the types of events we're interested in. If we see a request.getParameter, then we're interested in whatever it returns. And since we're storing that inside source object, and source object is one of our returns things, then that means that is one of the returned objects from this. So source, if you have something where you say get parameter, rec.getParameter, then that will be one of your sources. So you would taint it, right? Now alternatively, if you see rec.getParameter values and you store that array in something else, then whatever that array is will end up being what you return through source object. right? So the assignment to source object in that third pattern in source tells us that that's what we're returning. We're returning the array as the object of interest in that case. So the entire array is of interest. And so that's how we identify what we're returning, the things that we're interested in, and then the patterns. Okay, that was just tedious. There wasn't any need to do that at all. So it actually did make sense. There wasn't any question about what the queries meant. Okay.
Well, before this, there's something that they claim in the paper. They made some precision improvements. That is in case of handling of containers, which they say that when you're inside, when something, as he mentioned, that when you have something inside a data structure, it is generally difficult for the previous points to analysis to analyze that. So what they propose is that they give a different object name to every different object inside the data structure, which makes it more precise. Then they claim that they have also taken care of handling string routines. Now, this is really interesting. So, if you have an object calling string to lowercase, the string to lowercase always returns the default object name. Object naming scheme, right? So, the problem is that if you have different objects calling this method, and if one of them is tainted, all of them are marked as tainted in the previous approach. In this approach, they claim that we can have different names, different object names from the method, the lowercase being returned, and so we can identify them differently, which helps improve precision and reduce false positives. Any questions? Any discussions?
I'm actually a little surprised by that based on some of the sensitivity arguments, but interesting.
Moving on. That's the whole overview of what's happening.
So almost the results.
Yeah.
On time.
On time. Okay. So this is BDD. That's binary decision diagram. Something. Detective decision database. So
I should also say this is also something that is available to you, and is a fine tool that you could use for a term project. It is actually a tool that is available to you that you could use for stuff though.
Like for what?
There are lots of problems that can be reduced to data log problems, it turns out. And if you can reduce a problem to data log, then you can solve it very, very efficiently. Because it's all based on that binary decision diagrams.
it means
So it's
binary decision diagram, deductive.
It's a language for querying. Basically.
There is binary decision diagram based deductive database.
They really, really wanted to torture people with that.
Right.
I
It's
do like it.
funny, I'm using BDDB.
BDDB, or whatever stuff. Moving on to the results. Okay. So there's something interesting about the benchmarks that they chose. That is marked somewhere. Well, they claim that these benchmarks were selected solely on basis of their popularity and
At the time.
the size at the time in 2005. And they say that even though this is just 140 lines, don't be fooled, since this has libraries being used, and just look at the number of classes being analyzed. That's what they say to justify their choice.
There's an element of truth to that insofar as the complexity inside Java does scale with respect to the class size.
Right.
However, number of lines, total number of lines or number of instructions or whatever considered does play a role.
Okay. Moving on to the results. Well, the ticks basically mean what they're using. They're both, two ticks means they're using both context sensitivity and improved object naming, the one we talked about. So they claim that they were able to find actually 41. They claimed 41 vulnerabilities, out of which 29 were accurate and 12 were false positives. So the interesting thing to see is that all the false positives are in this case. Let's not. Do we want to discuss on this?
We could.
Sure, we have time. There's only one more slide left.
So what was the issue?
What was the issue?
What the developers wrote it in a non-standard way.
So
It
there's
caused some issues.
a certain element of sensitivity then to whether or not something is idiomatic, right? Whether or not it is written in a standard way, which
Is this the one they claim that they can change the source code?
Yes.
Interesting.
so that is interesting. But so do people have thoughts on that, right? This code was written in a non-standard way, and as a result, the analysis.
But then they're saying that it's programmer's fault.
To a degree, it is.
It always is. So
Why is the programmer's fault? What do you mean?
they say that it, had the source code been written in a proper way, we would not have had these false positives.
Or in a more standard way. There's an argument for saying that if the code were written in a way that were just more maintainable in general,
Right.
if it were higher quality code, then they wouldn't have flagged it. Now, for things like either security vulnerability detection or bug detection, that might tell you could just look for code that is non-idiomatic.
What does
And-
idiomatic mean?
That is written in a non-standard way.
Okay.
And, you know, that's pretty good too.
You can just claim it as false.
Well, I mean, you might have some false positives, but that kind of gives an indication that, well, things that are non-idiomatic are just more likely to either be flagged by whatever analysis you've got, or to actually be vulnerable. And the results from your analysis might be not entirely different than something that is extremely precise.
But they claim that the imprecise object naming was responsible for the 12
Okay.
false positives. Under the section handling of the string routines for crew, the last paragraph,
All right.
it
Yeah.
says as explained in section 6 for imprecise object naming was responsible for all the 12 false positives.
Sure.
So it means that the programmers were not careful about naming the object.
Oh.
Or-
Let me actually go through that a second again real carefully here. That is not what that would mean.
Yeah,
That
so
would
it
not-
means their own naming, right?
Right,
So it's
right.
not the same thing.
No, that is not. That's, yeah, so you can see that I skimmed through this. Last time I read this was 7 or 8 years ago. I missed that one. Right.
No, but aren't they giving the object names in case of strings?
Yeah, so naming is kind of their method for distinguishing things. So a fresh name is like a fresh identifier, fresh context, and so forth and whatnot. So if things have the same name, then analysis for those things will be coalesced. Yeah, so this isn't developer issue. This is the precision of the underlying analysis.
Right.
Interesting, okay.
That explained in section 6.4.
Yeah, that's what I was looking at. So we talked before about how some of the tests I gave you for project 2 should report errors even when there weren't any.
Right.
This is an example of that.
But
It
even
was your fault or our fault?
Well, I mean, some of the issues with project 2 weren't my fault. That's true. But
It depended on the static analysis that we
it
did.
depends on a static approximation,
Okay.
right? And those approximations lead to these false positives. The question?
I just wanted to mention that even in section 6.4 they explain the same thing. So I don't
Yeah.
think they have mentioned the developer's fault anymore.
Yes, it's not, yeah. It is their naming issue. And that means that they're unable to distinguish based on their context sensitivity, some of these things, absolutely. And so that's why it ties back into, I gave you some tests in project 2 that had no errors, but should have reported errors. Because it's the same thing. They got a false positive for the same reason you would have gotten a false positive.
But you mentioned we get false positive because of level of context.
Right, the
But
approximation.
this one was.
Well,
they
that's
were totally
that's the notion of naming. So, you know, a given context names something.
A given context name something.
Yeah, that's how you identify things, right?
Oh.
Is based on the context sensitivity and,
So level 2 is like the name for the thing that you're at.
yeah, like that sequence of call sites was the name for something,
Okay.
right? No, it turns out that what they're doing is actually combining a couple different types of context sensitivity. They used call site context sensitivity and object sensitivity, which is a different type of context sensitivity, and combine those together to form their names.
Oh, is it because of object sensitivity? Because first I thought false positive would be because of the object, like the access path. That might be like.
It's the combination. It's the combination. So the sum total of their naming is imprecise, and their naming includes things like the object access information and the call site information.
There's this neat little bar graph that tells you the number of tainted objects found. And in their more precise case, they're always, you see a decrease in the number of tainted objects. That's the last one. It's always less than the previous ones. That's the last one. That's just, they classified the errors. And you can see that parameter manipulation right there. That's the most seen cause of security flaws, and then there's HTTP splitting as well.
And this is maybe not true anymore, right? The nature of these results is a good 10 years old, and the nature of attacks that are prevalent today is not the same. Because some of these things people just know about enough nowadays that they usually don't do the really stupid stuff anymore. You know, every now and then the stupid, well, not infrequently, I guess, the stupid stuff still happens, but the non-stupid stuff is exploited more and more. That's it. Thank you. Sure. Just in time.
So I've heard that SQL is not used a lot anymore. So can we like do the same?
Well, it's still very much used. Yeah, most databases.
What do they use in C? What do people use in C? They don't use SQL.
Yeah, there are other types of databases. So SQL is
So can we perform the same thing for